Okay, today guys, we're going to be talking about 10.4 ellipses and graphing equations of ellipses. Okay, so this is a little different than what we were doing yesterday. Yesterday we talked about a circle where you had a center and all of the points on the circle were the same distance from that center. Ellipse is a little bit different. I'm guessing that you're looking at it and saying it looks a little bit like an oval. And it does. It does look like an oval. And the definition, I want you to write it down, the definition is a set of all points, and we're going to call those points P, such that the sum of the distances between point P and two other points called foci is constant. Okay, what does that mean? Well, here's this ellipse, and I'm going to just draw some lines through it. Okay, so this is actually a horizontal ellipse because its length is along the x-axis if I put it on the coordinate plane, and the horizontal length is longer than the vertical length. So these points right here are called vertex. And these points right here are called the co-vertex. Okay? Those two fixed points that we call foci, they actually lie inside, okay, somewhere about here. Maybe a little bit closer to the vertex, depending. And so if I put a point P on the graph, okay, then the distance, sum of the distance, or the sum of the distances between those points is going to be constant. So again, it does still look like an oval, and we're going to do some interesting things with ellipse. We're going to move it and shift it and move it up and down, and you're going to see that it's really not all that difficult to work with. But again, all of these different figures we're going to kind of put together at the end as well. Okay, so let's look at the differences. So we've got to talk about ellipses with a horizontal major axis or a vertical major axis. So I'm hoping that you recognize this has a horizontal major axis because the horizontal distance is longer than the vertical distance, okay? And let me move this up a little bit so you can see, and I want to make sure you're able to see everything. So the first thing that we should probably talk about is the equation of ellipse in standard form. First of all, a couple things you need to know about an ellipse. You need to know that standard form is going to have a center at 0, 0. So the ellipse's center, if it's in standard form, is going to be at 0, 0. Now, that's not to say we're not going to shift it and throw in that HK that we did with circles. Additionally, there's going to be some other variables we throw in there, and those variables are A and B. Well, A always is going to be greater than B, and B, both of those have to be greater than 0. So those are two things that you're going to need to know from the standard form of an ellipse. Okay, so the standard form, if the horizontal is the major axis, would be x squared over a squared plus y squared over b squared equals 1. Now I'm hoping that you're noticing something. First of all, I said that a had to be greater than b, okay? It's horizontal because the denominator of x squared is greater than the denominator of b squared, the denominator of the y squared, okay? The vertex of this are going to be at the point a, comma 0, and negative a, comma 0. So here and here, okay? The co-vertex are going to be at the point 0, b, and 0, comma, negative b. So at the top and at the bottom. And those 2 points called the foci we can find by doing c squared equals a squared minus b squared. Be really careful because the Pythagorean theorem says c squared equals a squared plus b squared. This is different, okay? So the only difference between the horizontal and the vertical is going to be the equation where a lies. So the equation in standard form, if it's a vertical major axis, is going to be x squared over b squared plus y squared over a squared equals 1. So the a squared is the denominator of the y squared is greater. Denominator of y squared is greater. The vertex, and it's going to slightly change now. So these are going to be my vertex. So those points are going to be 0, a, and 0, negative a. Because think of the coordinate points at these points. That's where x is 0, and then y would have a value. The co-vertex are then going to be at b0 and negative b0. And we're going to find the foci the exact same way. C squared equals a squared minus b squared. And again, guys, I put this in a chart format for you so that you have something to kind of look at and refer back to if you need it. And I'm just going to step behind the camera for a second, just make sure you can see everything. Okay, good. And let's go on and look at some real examples. Okay, so I'm asking you now to identify the vertices, co-vertices, and foci of the ellipse. But every single time you do an ellipse, I want you to think about, is it horizontal or vertical, and why? Okay, so that's going to be really important when you do these. So I look at this and I say to myself, okay, my denominator of my y squared is greater, so that means it's going to be along the y-axis, so it's going to be vertical. Okay, why? Because a squared is greater, okay, and it's under y. Maybe that's how I should have said it in the first place, so we'll think about that one, okay? And it's under the y squared. My vertices then, so just think about what that vertical looks like, okay? My vertices are going to be up here and here, so it's going to be where x is 0. So 0, 6. Remember, this is a squared, so we only want a, and 0, negative 6. My co-vertices then, we look at our b squared, and again, it's along the horizontal axis, so that's going to be 4, 0, and negative 4, 0. Okay, now we have to look at our foci. Our foci we're going to use that formula, c squared equals a squared minus b squared. Okay, so c squared equals, my a was 36, because a is always larger than b, 36 minus 16, which gives me c squared equals 20. Take the square root of both sides, so c equals plus or minus 2 root 5, okay? Because I simplified root 20. Now I do want you to think about where that is. And root 20 is somewhere between 4 and 5, isn't it? Because the square root of 16 is 4 and the square root of 25 is 5. You are going to need to know that when you graph it, approximately where it is. So I want you to stop and I want you to think about that every time, okay? All right, so let's go on to the next one. X squared over 196 plus y squared over 100 equals 1. And actually I need to stop a second. I'm going to jump back here because I don't think I really did a good job pointing this out. If it's in standard form, this ellipse, it has to be equal to the number 1. If it's not, you're going to have to do something to it to get it equal to the number 1, okay? All right, so let's go back to our, and again, this is in standard form, it is equal to the number 1. We want to identify, is it horizontal or vertical, okay? So I look at it and I say, okay, which number is bigger? 196, so that's got to be my a, right? And so the a squared is under my x, is the denominator of my x, so it's horizontal, all right? And why? Because denominator of x, that's better. Denominator of x is greater. Okay? All right, so then let's look at our vertices then. So I want us to think about this now. So it's looking something like this. So we have to consider those coordinate points there. So that would be 13, 0, and negative 13, 0, because remember, remember this is a squared, so we just want a, okay? My co-vertices would then be the opposite, so 0, 10, 0, negative 10. Now I want you to think about it. We said the center of this, if it's in standard form, is at 0, 0. So the length of the major axis, if this is A and this is A, the length of the major axis would then be 2A, and the length of the horizontal axis would be 2B. And that's going to come into play when we start shifting this. You're really going to want to think about that because there's that symmetry going on, okay? All right, and then again, if we want to do our foci, we do c squared equals a squared minus b squared. So c squared equals 196 minus 100, and c squared equals, squared was at root 96. And again, we're going to simplify that as well. So go ahead and simplify it, and ask yourself what's the largest perfect square that goes into it. And let's see, that would be, so 16 goes into it. 16 goes into it 6 times. So it would be 4 root 6. So c equals plus or minus 4 root 6. And again, where is that? Well, root 100 is 10, root 81 is 9, so it's really, really close to 10 when I graph that, okay? All right, now I want you guys, we're going to save this last one for class tomorrow, okay? And let's go on to graphing. All right, so here's an example of graphing an equation of an ellipse. First of all, remember I said x squared over a squared plus y squared over b squared equals 1, and this is not equal to 1. And I don't have fractions here. I don't have a variable in the denominator, so I need to somehow get that. So in order for me to make this side 1, the only way I can do that is if I divide by 144. So I'm going to divide everything by 144. So that would be step 1. Always put it in standard form if it's not. Once I do that, I'm going to get x squared over 16 plus y squared over 9 equals 1, okay? All right, so then we're going to identify whether it is horizontal or vertical. So I look at where my a is. A is always my larger one, and my a squared is under my x squared, okay? So that means along the x-axis, so it's going to be horizontal. Y again, and I want you to write this every time so that you understand it, because the denominator of x squared is greater. Greater, there's me writing my or, that's not wrong. All right, so what are the vertex? Okay, so let's think about what our graph looks like. So I'm just going to go ahead and do this. We know that they have to, the major axis is along the x-axis, and it's horizontal. So that means my x is going to have that value, and y is going to be 0. So it's going to be 4, 0, negative 4, 0. Okay, so then my co-vertex are going to be the opposite. So that's my b squared, so I only want b, so 0, 3, and 0, negative 3. What are my foci? Again, for my foci, hoping you can still see all this, we do c squared equals a squared minus b squared. So c squared equals 16 minus 9. C squared then equals 7. Take the square root of both sides. So c is going to equal plus or minus root 7. So be careful, I don't want you to forget, whenever we take the square root of both sides, we're always going to consider that plus or minus. And I know some of you were starting to forget that, but that is something we've talked about the entire school year, okay? All right, so then we plot our points. So we're going to go over here, and we're going to do 1, 2, 3, 4, 1, 2, 3, 4, and I'm going to put a point there. And then we're going to go 1, 2, 3, 1, 2, 3. And we're going to do our best job here. And then I'm going to also plot my foci. My foci is between 2 and 3. So here's 2 and 3. It's going to be right about there. Again, we don't have to be absolutely perfect because we can't, but, and then we're going to, let me get blue. We're going to connect them, and it's going to look like a nice oval. Okay? All right. Where do we see ellipses? Well, I can think of one in DC right now, the ellipse, which is the front area of the White House. Okay? So that actual shape you're going to see in lots of different places, buildings, structures, streets, gardens. So city planning, important. Okay, architecture, important. All right, so now I want you to try. So I gave you an example. Graph the ellipse x squared over 12 plus y squared over 36 equals 1. So this would be a good place to pause it and try it, okay? Giving you a second to do that. Okay, so now I look at it, and you've just turned the computer back on, or you've just pressed pause because you did the problem on your own. So it's already in standard form, it equals 1, so I don't have to worry about that. So next I'm going to say, is it horizontal or vertical? All right, so I need to identify my A. A is 36, and it's under the y squared, so that tells me it's a vertical ellipse, okay? And why? Because denominator of y squared is greater. Okay? And then I have to identify my vertex. Okay? My vertex, because it's a vertical axis, and I'll do that. We know that this is going to be the longer of the two lengths, and that's where x is 0, so it's going to be 0, 6, and 0, negative 6. So my co-vertex are going to be the complete opposite. So 0, now here's where it gets confusing. This is actually b squared. We just want b. So it's the square root of that, root 12. Sorry, root 16, and 0, negative root 12. All right, and that's why we're going to have to know where those points actually lie. And then we've got our foci, which is c squared equals a squared minus b squared. And our c squared then equals 36 minus 12. C squared equals 24. So c equals plus or minus root 24. Do want to simplify that, so c would equal plus or minus 2 root 6. I'm hoping you got that when you pressed pause. All right, I'm going to plot my points. I'm going to go to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm also going to plot my co-vertex. Now you need to know, think about where root 12 is, guys. Root 16 is the number 4, root 9 is the number 3, so we're somewhere in between. You do want to grab your calculator and just estimate, you can as well. So I know I'm going to be between 4 and 3 somewhere, so this Frederick's just going to go somewhere right about there. I'm also going to plot my foci. Now be careful, because the foci always are going to go in between your major axis. So root 25 is a little bit less than 5, so 1, 2, 3, 4, 5. Right about there, and 1, 2, 3, 4, 5, so right about there. And then I'm going to connect my vertex in a beautiful, nice, beautiful oval. Okay, a little bit hard on the smartboard. All right, so the last thing we need to do is we need to be able to write an equation of ellipse that with a vertex, okay? So this can get a little bit more challenging, so you have to think of what the coordinates represent. So for this first one, I'm actually going to do this. 0, 7 is right here. 0, negative 7 is right here, right? So it's saying the vertex is that. So it's got a vertical. It's a vertical ellipse. So that means that my y squared denominator is greater. So that means, here I'm going to take my equation. So that means that my a has to go under my y. And this is just a, but remember a squared goes under the y, so it would be 49. And then I look at my b, which is negative 6 here, okay? And I want my b squared, which would be 36. And there's my equation. Okay, so I want you to try the next one, and then I want you to press pause now and try it, okay? Okay, so if you did this one right, slightly different. My vertex is 9, 0, so my vertex is along the x-axis, so that tells me it's going to be a horizontal ellipse. So again, x squared plus y squared equals 1. So if it's a horizontal ellipse, my denominator under my x is larger. Since this is a, this is going to be a squared, so 81. My b is 8, so this is my b squared is going to be 64. Okay, and that's it for today, guys. Tomorrow we're going to kind of review this and just practice in class, and we're going to do some actually applications and word problems with this, so you can kind of see where in the real world we're going to use ellipses and why they matter. Okay, have a great night. Bye. Oh, and don't forget to bring your notes to class.